Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. Welcome to the last module, which is 10th module. In 10th module, we will learn about sequential files. The question is, what is sequential files? Sequential files are used so that the result of an executable program can be stored permanently in any storage device, not temporarily disappearing when the program is closed or stopped. The goal is that the data that has been stored can be reused. For example, when you create a program without using a sequential file, the input data in the program or the data that will be run will be deleted when you close the program. When you want to open it again, you will return to re-enter the data. But if you use a sequential file, the data that you input or data that will be run will be stored permanently and you can use it again when you open the program. An example is the login registration program. In this program, you have to create the next account in order to continue the next program. When you register, your account will be stored permanently in the program. So, after you close the program, when you want to open again, you don't need to re-register. You only need to log in, use the data that you have registered before. The C language provides a structure that can be used to store all the information needed to control the data flow of file. The file structure and declared in the standard studio.h header file. The structure will store a file current flow information, which includes a file position indicator, a buffer pointer, an error indicator, an end of file indicator, and any other information needed. The first way must be done to get information from the structure file is declaring a pointer that will point to the file structure. A pointer is called a file pointer. The general form is like this: file asterisk file pointer identifier. You can fill in the pointer file identification with whatever you want. Here for the example: redis file asterisk fp. Next, you also need to know what the file operation stages are in sequential files. The first is open or activate the file. Before a file can be processed, the file must be opened first. Use a function called fopen. The general form is like this: file asterisk fopen file name mode. An example: fp fopen test.txt w. The fp is the pointer file, fopen is the command to open the file, test.txt is the file we are going to process, and w is the mode of the process. After this, I will explain what the modes are in sequential files. So here it is, the existing modes in the sequential file C language. The first one is R. It means open the file for reading process. If the file does not yet exist, the file will fail to open. Meanwhile, if the file exists, then the file can be read with the file position indicator initially positioned at the beginning of the file. Next one is W. It means open the file for the writing process. If the file does not yet exist, the file will be created. If the file is successfully opened, then the file can be written with the file position indicator initially positioned at the beginning of the file. Next is A mode. It means open the file for the appending process. If the file does not yet exist, the file will be created. Meanwhile, if a file exists, it will cause the process of writing data to the file to be written at the end of a file. If the file successfully opened, the file position indicator will initially be positioned based on the implementation of a platform, whether at the beginning or the end of the file. Well, there are also modes R+, W+, and A+. Plus symbol, it called the update mode. There is R+ mode. It means the same as the R process, which is the reading process, but it can also be used for the writing process. Next, there is W+ mode. It means just like W, it will open the file for the writing process, but it can also be used for the reading process. There is also A+ mode. It means the same as A. It can also be used for the reading process. There is a lot of misunderstanding between R+ and W+. Actually, R+ and W+ are different. R+, it can open files that do not exist, while W+ can open the file that do not exist yet. The next stage is processing files. When a file is opened, the file can be treated as a binary file or text file. A text file is usually used to store data of type or string type. Meanwhile, binary files are usually used to store complex data such as structures. File format in text files is usually in the form of .txt, while for binary files, it is usually in the form of .dat. For the mode used in text file, we use the mode R, W, A, and the update mode R+, W+, and A+. But in the binary file, we add B at the end of each mode, such as RB, WB, and AB. For the update mode, we can use plus at the end of the mode or in the middle like this.
Now we're going to talk about how to write, read, and send data to text file. There are 5 subtopics. First is writing and reading string data in text file. Second is syntax write string data into text file. Third, syntax reading string data from text file. Fourth, syntax read string data from text file using fgetC function. And fifth, append data to text file and the syntax. To write and read string data in text file, we can use 3 syntax. First is fprintf for write, second and third fgets, and fgetC for reading string data in text file. If we use fgetC, fgetC will read strings from file by save the character as integer. Syntax to write string data in text file. This is the file pointer. This is the name of the file, and this is the mode because we're going to write, and don't forget to close because we're opening the file before. Next, we're going to syntax to read string data from text file. This is the pointer, file pointer. Don't forget to open our file text because we're in the right program. We use example.txt. So in this read program, you also use example.txt. We use R in this mode because we're going to read. And don't forget to close it. So this is the read string data using fgetC. The difference is in here, fgetC. The last is append data to text file. To append data to text file, we change the file mode argument in the as open function from W or W plus into A or A plus in the here. The difference between the append data and write just from the argument, this argument. Okay, now we're going to practice it in DevC. This is the write program. We're going to compile it and write. Enter. If we running the program, there will be this text because we make example.txt. Next, if this is the read syntax. If we compile it, there is write, because in write program we write the string write, and in this read program this is the syntax to read string data from text file. If we compile it, there is string data in our write program before. And this is the syntax using fgetC to read the string data. If we compile it, also write, same in fget's program. And this is the syntax and program to append data to string, append string. This is the syntax to append string data to file text. This the difference between write and append data just in this argument mode, because we're going to append it, we use A or we can use A plus. If we compile it and write append, read our text file after append, there are write and append, because when we run our append program, we write append string, and if we're going to read it again, there are write and append.
Next, we learn three function binary file. There are writing, reading, and editing data. There are two functions to write or reading data in the form memory block. For example, for writing any data type like float or struct. For fwrite function, we can use WB or WB plus. For fread, we can use RB or RB plus. To declare is look same between writing and reading that distinguishes is within the function only. To writing, use fwrite function will learn. To reading, use fread function. PTR is pointer that points an area memory that will be used as temporary data storage for reading from file for fread, or for writing data into file for fwrite. Since the size of memory block is byte to read or written, EMB adds the number of memory blocks to be read or written at one time. Stream is a file pointer that points to file. For example, we can look at the bottom of the box. For PTR will be list, size will be size of, and EMB will be 1, stream will be fstructure. Okay, we will try to source code. Before that, we will declaration pointer or file. file star abstractor. Then we use an integer data type to in with variable e and n. Because we use binary file, so that we use struct, we use menu and price. To menu we use char, and to price we use double. Open file use fopen and use type data.dat with wb mode because we will write. The input that, the menu and the price. After all of input will save in abstractor file with use fwrite. Then to close file with fclose. We are trying input. Please input the amount of menu to menu satay price 7,000. Second menu soto price 10,000. All that we input was then stored in the file.dat. Second, reading data source code. To read data, the source code is lost because it's only read. Reading data only need output. First, we open file with fopen and use type data.da with rb mode because we will read. For reading, we use a read function. When reading is correct, so we'll show the menu and the price. After that, we close use fclose function. Okay, let's run the program. It will appear the menu and the price have been we input, but when we don't any input, so in part of the read output is empty. Editing data source code. To editing data, its source code will be same with writing. Use AB mode only. Here, we add the end of the old data and automatically fill the under the old data. Okay, let's try. To storage price 4,000. Chicken noodle 5,000. The input data is super. To be at the bottom of the all data are satay and soto. Okay, let's see in part of read data. The data we enter early will be added to all data. Data that input last will be at the end of the all data. We are porridge and chicken noodle under satay and soto.
Accessing binary file or fsig. The general form in fsig we can see here at the gray box in the PowerPoint. And in fsig general form there are stream, long integer, offset, and integer lengths. Here are the description. Stream is the file pointer. Offset is the value of the byte adjustment to the length reference, and the length reference is the file position indicator reference. Suppose the data is in the middle of a file. The data must be read directly without having to be accessed one by one starting from the beginning of the file. If the operation fails, it returns a value other than 0 that is defined based on implementation of the platform. After a successful fseek call, the next operation in the update data stream can be input or output. Okay, here are the table of friends. They are micro and local file reference. We use seek set if the local reference is in the beginning of the file. Seek current is the current file position indicator, and seek underscore n is the end of the file. For example, we can see fseek, and then there are some file pointer, and there's some -3 or 3 can be defined as byte here, and seek n. Okay, there are some negative sign over here. This means offset can also accept negative values that indicates that the file is in the end of the file. So negative refers is before end of file, and we can replace byte by size of data, which means the byte of the data himself or the data itself. Okay, rewind function. The rewind function does not return a value. Okay, change the file indicator for the data stream pointed by the stream to be in the beginning of the file, except there are errors indicator on the data flow is also deleted. This is the definition of rewind function, and the general form in rewind function is void fseek stream 0l and seek set. Okay, this is the source code of using fseek. They are the file pointer f underscore structure, they are f open, and when we use fseek we obviously use read binary. Okay, this is the offset byte, the size of daftar, which means the byte is related to the daftar struct, and we use seek underscore set to know the local reference of the file we are looking for, and which file that we are looking is in the f underscore structure, which is the pointer of the daftar harga file. Okay, remember we are going to read this file because we are seeking them or we are searching them, so we use fread over here, and remember every fopen must be ended by fclose over here. Okay, so this is what it looked like when I execute this source code. Wait, there. Okay, we're gonna there are 3 menus that I inputted in the last video: beef, chicken, and fish. Maybe we try beef, chicken, fish. Maybe we try 2. See, this means that the program works and it find it the data is chicken. Okay, so we find chicken among 3 objects that I input, which is beef, chicken, and fish, and this is how fseek works. Deleting data in binary files. There are 2 ways to delete binary files: by removing and renaming the files. Okay, you can see here the general form is integer remove and integer rename. Here are some procedure to delete binary files. The first one is opening the main file without read mode. The second one is make a backup file and open the file in write mode. Third, copy all data from the main file into a backup file, accept the data to be deleted. Fourth, close the main file and backup file. Fifth, delete the main file. Sixth, rename the backup file based on the main file name. 7, delete the backup file. So this is overall the procedure. I'm gonna show you the source code of deleting file. You can find it in your module as well, but I will show you how does it work later on in DevC. Okay, this is the source code for removing or deleting data. Okay, in here we use two file pointer, which is f_structure and f_structure2. Okay, we have daftar harga and daftar harga2. Remember, we have to make a backup file for deleting file or deleting data in file. Okay, in here we open both the main file and the backup file, and over here we input the data that are going to be deleted. After it is deleted over here, this process shows that the remains of the data will be copied to the backup file. Okay, and when the action is finally done, we use fclose to close the file. Remember, fopen must be ended with fclose. Okay, and then we use remove and rename method, just like over here. Because all of them is copied into the backup file, we can safely remove the main file. But to not confuse the program that there's only one main file, we use renaming method. So we rename the daftar harga2 into daftar harga again. So in this daftar harga, the new daftar harga, the deleting data is successful, and only remains data that aren't deleted. Okay, so here how it works. Wait, here, this is when I execute the program. So silakan masukkan nama menu yang akan dihapus. What menu should we erase? There are beef, chicken, and fish. Maybe we try fish this time. Okay, so I'm gonna input fish. Okay, this shows that the data in the file has been deleted or terminated. Okay. We're gonna prove this if the program works in reading the binary file. Okay, I'm gonna show you later. Wait. Okay. To prove that the data in daftar harga is successfully deleted, we use fread this time. So here we go again. The file pointer f_structure, and we open daftar harga in read binary mode, and then this is the action that will be done in the file, which is reading the file, and then we close the file. So we are going to prove you that fish is in the menu or not. So when I execute this program, it turns out that fish has been deleted in the data, which means that the deleting data works. Okay, the last one is closing file, or we know it as fclose. The general form in fclose integer, fclose file, and stream. Remember, stream is a pointer file. If the fclose function is successful, it will eliminate the file data stream pointed by the stream and close the file in question. Fclose returns 0 if the data stream has been successfully closed, or IOF if an error has been detected. EOF. Sorry. Every fopen must be ended by fclose. Remember, if you learn file, if you open a file, you have to close it too. So this is an important matter. Here is an example of where the fclose used for. We see here in the red box in the source code, the user is opening the file, and then the user take action on the file, and when there is fopen, there also fclose to terminate. All the action are done. So closing file also means we are done changing whatever we change on the file. Okay, to empty the buffer in data flow, this is an extra module, so I'm gonna share you the theory of it. Data buffer for the writing process that has not been written into flow of a data will be written first. The general form to empty the buffer is flush. Okay, so which means flush empty the buffer in data flow. The flush function will set an error indicator for the data flow and return the EOF value if an error occurs. Otherwise, it will return 0 value. Okay, here's an extra one. Writing and placing file positioning indicators. The general form in writing and placing file is fgetPost and fsetPost. Okay, both of these functions will return 0 integers if the operation is successful, and otherwise defined based on the implementation of a platform if it fails. Here are some description. Stream is a file pointer, we know that before. fpost_t is a data type that can store information needed to uniquely determine each position in the file. And fgetPost will save file position indicator in an object that are pointed by post, and fsetPost will change the position indicator of file by the value of the object that pointed by post. This is in the module of yours, which in the extra section, but most importantly, we learn about opening file, deleting file, or take action in some file, and closing the file. That is the most important thing in file sequential.
Before the video ends, we have an assignment for you. Please create a new program to delete one of the desired national identity card data based on A. Residence ID number, and B. Resident name. The odd name does point A and the even name does point B. Before you make a program that can delete the data, you should know that there is a program with a binary files in the form of national identity card data that contains ID number, name, place of birth, and gender. For example, I have a file that already exists 3 data. The first ID number is 32101 with the name Asep Encep. The second ID number is 32102 with the name Nengsi Sukaisi. and the last ID number is 32103 with the name Irasumira. The old name does point A, so you can input the ID number that you want to be deleted. For example, I want to delete the first data, so I input 32101. Then the output will only be 2 data without the data with the name Asep and Chep. And for the even name, that's point B, so you can input the name that you want to be deleted. For example, I want to delete the second data, so I input Nengsi Sukaisi. Then the output will only be 2 data without the data with the name Nengsi Sukaisi. Alright, that's it from me. I hope you can understand it and do well for this program. See ya!